Okay, so let's continue with the review. Example. Let f of x is e to the power of 2x. Okay, so find the 100th derivative of x. Okay, and find the nth derivative of x. Okay, that's one question. And second example. Find the equation of the normal line to x3y minus 2y cubed minus x plus 3y equals to negative 11 at point what? Negative 1, 2. Okay, so the normal line, just for you to know before you start working on this, the normal line, so you have the curve, you have the point. The normal line is, of course, perpendicular to the tangent. This is the normal line. Okay. So the idea for the first one here is just to do a few derivatives until we recognize a pattern. Okay, so of course we have f of x is e to the 2x. F prime of x will be 2 times e to the 2x. F prime prime of x will be 2 power 2 e to the 2x. And so obviously the 100th derivative will be 2 power 100 e to the 2x, right? That's okay? And if you want to generalize, then the nth derivative is 2 power n e to the 2x. Okay, easy? It's an easy question. Second one. So we need to find the equation of the normal line. So to do that, we need first to find the slope of the tangent, and then find the negative reciprocal to find the slope of the normal line. Okay, so we use implicit differentiation here. So 3x2y, don't forget that there's a product rule here, plus x cubed y prime minus, this will be 6y2 y prime minus 1 plus 3y prime equals to 0. Okay, so I'm going to need to find y prime. So I could either isolate y prime right away, or might as well just plug in x is minus 1, y is 2 to get y prime at that point right away. So it's easier this way. So let's plug in minus 1 and 2 here. 3 times minus 1 squared times 2 plus negative 1 cubed y prime minus 6 times 2 squared y prime minus 1 plus 3y prime equals 0. And so I have 6, let's do extra steps, so 6 minus y prime minus 24y prime minus 1 plus 3y prime equals 0. And so y prime is equal to, so this is minus 25, minus 25 plus 3 is minus 22. So 22, so 5/22. I don't know if that's what you got. Maybe I made a mistake.
Oh, yeah, that's what I got.
So you
Yeah.
get 5 over 22. Okay, so 5 over 22 is what I got for y prime. And so the slope of the normal will be, you just flip it and change the sign. So -2 over 5. So I have a point, I have the slope, I can find the equation. Okay, so y minus 2 over x minus 1 equals to that slope. And so you have y is equal to -22 over 5x, and minus 22 over 5 plus 2 is minus 12 over 5. Is that what you got?
Yeah.
And this is the equation of my and a normal line. Okay.
I think someone's in the waiting room.
Okay, so plug in now, x is 4. And if, of course, if x is 4, y is 5, by Pythagoras. So 4 times 4 is equal to 5 times dy dt. And so dy dt will be 16 over 5, just like the answer is. Sorry. Okay. Determine all values of x where y equals x3 ln of x2 has horizontal tangents. Another one right here. The motion of a particle is given by S is equal to TQ minus 3T2. Okay, where S is in meters. And T is in seconds. Okay, so one, find v of t and a of t, so velocity and acceleration. Second, when is the particle at rest? Okay, and what is the acceleration at the time? Find the velocity at 4 seconds. It's for when is the acceleration zero? Okay, did you have time to copy the first one? I guess you did. So here's the second one. Okay, the first one. So when is the horizontal tangents? In other words, when is the derivative equal to zero? So let's find y prime. Product rule. Well, before that, I could have done brought the 2 in front, but anyways, let's see, you didn't see that. So let's do the product rule. 3x2 ln x2 plus x cubed times derivative of ln of x2 is 1 over x2 times 2x. If I put the 2 in front, I get 6x2 ln x plus, and this will be 2x cubed. 2x squared. And that is equal to 2x2 times 3 ln x plus 1. Okay, so y prime is equal to 0 if what? Either x is 0 or 3 ln x plus 1 equals 0. Sorry, which means that x is e to the power of -1/3. So these are my two values where x could be 0, where the tangent is 0, but we have a problem because the function is ln of x2. As you see, at 0, it doesn't work. Okay, so this is the trap here. So you have to be careful. You have to reject this one. Okay, and just accept this one. Okay, so you have to be careful about this, since the domain is everything but 0. Okay, it cannot be 0. Doesn't work. It works for every other value besides for 0. Okay, so that's a trap here. Be careful. Second question. Okay, so this I think is pretty straightforward. I want to try to fit everything in here. So number 1, v of t is just the derivative, so 3t2 minus 6t, and a of t will be the derivative of that, which is 6t minus 6. That's 1. Number 2, when is the particle at rest? So basically, when is the velocity equals to 0? So v is equal to 0, which means that 3t times t minus 2 is 0. So either t is 0 or t is 2. Okay, and the acceleration at each place, so on the acceleration at that time. So acceleration of 0 and acceleration of 2. So you plug in 0 in the acceleration, so it's minus 6. You plug in 2 in the acceleration, you get 6. That's for number 2. Number 3, find the velocity at 4. So v of 4, I just plug in 4 in here. So 1648 minus 24 is 24. Okay. And when is the acceleration equal to 0? So a equals 0 means that 6t minus 6 equals 0, so t equals 1. And that's it. Okay, it's a very easy question.